So in section 5.6, we began talking about special segments that can occur in our triangles, okay? And the few that we talked about were an altitude, an angle bisector, and a perpendicular bisector. This was some of the few that we talked about so far. So we need to determine if each of these figures, which of the following terms apply to these figures. So for number 3, for example, okay? So we are asked to determine, is it an altitude, an angle bisector, a perpendicular bisector, or none of the above? Well, if we see right here, an altitude would have to start from a vertex and then drop down to be perpendicular with the side. So since this line doesn't start from a vertex, that's not going to help us. An angle bisector also would have to be starting from a vertex as well, because an angle bisector would be cutting an angle into. So this line isn't going to classify as an angle bisector either. But one thing we can classify it as is a perpendicular bisector, and the reason seeing is that we see that this line, as it cuts through the shape, it creates a right angle. And remember, anything that is perpendicular to a line is going to create right angles. And we also see that these two sides, they have that one tick mark. So they have the same number of tick marks, which tell me that they are congruent to each other. So this supports our claim that this line for this triangle is a perpendicular bisector of the triangle. Okay, number 4. So number 4, again, we're starting from the vertex this time. Okay, I don't see any lines over here, so that's not telling me perpendicular. I don't see any right angles forming at all. So I'm thinking it's probably not going to be a perpendicular bisector or an altitude. But what do see? I do see that this vertex is getting cut by this line, and the two angles right here have the same number of curves right here. So that tells me that these angles are going to be congruent to one another. So because of that, for number 4, the line in this triangle is an angle bisector because it creates two angles that are equal to one another. Okay, let's scroll up. So for number 6, number 6 looks a little bit weird because the line is actually outside of the triangle that we've drawn. Okay, but if you remember, the definition of an altitude, which I'm kind of already giving away the answer, but hey, the definition of an altitude is a line that's going to start at a vertex and is going to come down and be perpendicular with the side opposite of the triangle. Now, for this one, there was no way to draw the altitude so that it would be perpendicular here, but an altitude can exist outside of my triangle. So because of that, this thing is going to be an altitude of this triangle. Okay, so now let's look at number 7, okay? So we know that an altitude and an angle bisector have to start out at one of the vertices, one of the vertex. And since this line is not doing that, we can go ahead and take out altitude. We can go ahead and take out angle bisector. So what about a perpendicular bisector? Okay, a perpendicular bisector can cut in the triangle at any point, but it does need to create right angles. And as you can see, there's no right angles that are being formed here. So because of that, this one is going to be classified as none of the above.